Hey guys, Mr. T here, another video. This one is on standard deviation. So this is a pretty complicated concept. Hopefully this helps you out with understanding it. And the example should sort it out for you. If not, you can watch a video online. So the range and interquartile range, which we've talked about in the previous videos, only involves two data values in their calculation, so they're not really that reliable. The most widely used measure of spread, so the one that you're going to be seeing throughout life in general, is standard deviation. And so what's the most basic explanation as to what the standard deviation is? It is a measure of the overall amount that all of the data values in a set deviate from the mean of that data set. So how far is all the data from the middle of the data set? All encompassed by one single number, which is the standard deviation. There's two standard deviations you're going to find. The population standard deviation, symbolized with this particular symbol. I forgot what the name of that symbol is. And the population standard deviation, and the population mean, is symbolized with that symbol there, mu. And the second standard deviation you'll encounter is the sample standard deviation. That's designated with the S, and the mean of that is x with a bar on top of it. So because populations are so big, we're only going to be dealing with the sample standard deviation, so sample standard deviation being S with a mean of x bar. So this is where we get to the complicated part, the maths part of it. Sample standard deviation is calculated with this, so sample standard deviation is S. Square root of all of this is underneath the square root, and this is sum of x take x bar all squared divided by n take 1. And so instead of explaining what each one of these means, I'm going to explain what the whole top line is. That symbol there means the sum of, and this is saying x, which is the data values themselves, take away x bar, which is the mean of the data values. And then you're going to square that number. So you can think of it as the difference between each data value and the mean. And whatever that difference is, it could be positive, it could be negative. You square it, and then you add them all together. So that top line is the sum of the square of the deviation of every data value from the mean of the data set. That's still really complicated. I try to simplify it, but it still sounds ridiculous. Hopefully it'll clear it up when I do the example. And then lastly, n is the sample size. But here it's n take 1. So you're going to square root whatever the answer to all of that is. So to help try and clear this up, this complicated explanation, complicated concept here, we're going to try and find the mean and standard deviation for the following data set. So you always need to, if you're finding the standard deviation manually, you always need to find the mean first, because you need to work out what the deviation of each data value is from the mean. You can't do that unless you know what the mean is. So our first step, mean of this data set is going to be 7 plus 11 plus 8 plus 2 plus 15 plus 5 divided by however many numbers there are. There's 6 of them. And so those numbers add up to, graphics calculator, 7 plus 11 plus 8 plus 2 plus 15 plus 5, 48 divided by 6, that's going to be 8. So the mean is 8. So now, here we get to the complicated part, is working out what the hell that means. So the easiest way of dealing with that is actually drawing up a little table here. So what you're going to do, x, or a column for x, which is the data values. X take x bar, deviation, so how far the data value is from the mean, and then x take x bar squared, whatever the deviation is squared. So, it's not even a straight line. Not that one's straight enough. So this table is just to help us work out the standard deviation. You don't need it, okay? So the first data value is 7, the next one is 11, the next one is 8, next one is 2, next one is 15, next one is 5, and then this one is going to be the totals. So hopefully this sort of clears out what the x take x bar means. We're going to work out what the deviation is. This is the x, the data value, and we know what the mean is, which was 8, is x bar. So it's going to be x take x bar, which was 8. 7 take 8 is -1. -1. And so we know that x take x bar for the data value of 7 is -1. Square it is going to be 1. Next one, 11 take 8 is going to be... So we've sort of gotten rid... We basically are trying to get rid of the negative and positive signs, because all we care about is how far these data values are from the mean. It's 1 away. I don't care that it's negative or positive. I just care how far it is size-wise. So 11 take 8, that's 3. 3 squared is going to be 9. 8 take 8, there's no difference, there's no deviation between this data value of 8 and the mean, so that's going to have a square deviation of 0. 2 take 8 is going to be -6. -6 squared is going to be 36. 15 take 8, it's going to be 7. 7 squared is 49. And 5 take 8 is going to be -3. -3 squared is going to be 9. So the total of this doesn't matter. We're totaling this up. So it's going to be 1 plus 9 plus 0 plus 36 plus 49 plus 9. 104. So now we know what the sum of x take x bar squared is 104. So we know we can work out what the sample standard deviation is now. 104 over n take 1. Well, n was, there's 6 numbers, so it's going to be 6 take 1. Square root of 104 on 5. 104 divided by 5. And then find the square root of that. Find the square root of 20.8 equals 4.56 to 2 decimal places. Okay, so what that's saying is the overall standard deviation, average measure of how far the data is from the mean, is 4.56. Sample standard deviation equals 4.56 for that set of data there. Now, you can quickly access the standard deviation easily on your graphics calculator if you just do stat, and then, so graphics calculator, graphics calc for standard deviation. How do you do that? You press stat to, like with all the statistics, you have to enter data into list in one edit. Once you've done that, you can press stat again. Go to calc. Calc tab with the arrow buttons and select one var stats. And so I'm going to do that now. I'll go 1. My data was 7, 11, 8, to 15, 5. So I entered the data. Step 3, press Stat again, select Calc, select one var stats. 5, set list to list with data entered. So in my case, it's list 1, and freak list to nothing. Select calculate. And then when you've hit calculate, statistics pop up. And the one that you're interested in is SX is the sample standard deviation. And with that data that I entered, you'll have to trust me because I haven't done this on the computer, my SX on one var stats comes up as 4.56, which is confirming what we did by hand there. Okay, so hopefully that helps you out with standard deviation. Hopefully it helps you with understanding what it is, how you'd work it out by hand. Most of the time you're just going to be using the graphics calculator to do it, but you need to do it by hand to understand how it works, and also because you're asked to do it using the formula sometimes. So hopefully that helps you out, and I will see you on the next video.